everybody. This is Michael with Michelin Metals, back again to talk about nickel. All right, so today is going to be our second part on nickel alloys. But before we jump in, I need you guys to do me a favor. Click that little subscribe button. Please, little bink, click that subscribe button. It's only 8% of you guys who are watching are subscribed. That means 92% of you people are not subscribed. So, help me out. Or give me a little thumbs up. Thank you very much. It would be helpful. Now on to the second part of nickel alloys. And in this part, we are going to talk about the family of three alloys of nickel and copper, which are Monel 400, Monel R-405, and Monel K-500. Compositions are roughly 2/3 nickel and 1/3 copper. These elements form a solid solution with each other, a stable mixture that cannot be made stronger by heat treatment. It takes certain additional elements to make an alloy strengthened by heat treatment. These three alloys are named Monel 400, Monel R-405, and Monel K-500 when produced by Special Metals Corporation. Generic versions cannot carry the Monel trade name. Monel 400 or Alloy 400 contains a minimum of 63% nickel plus cobalt, 0.3% maximum carbon, 2% maximum manganese, 2.5% max iron, 0.5% max silicon, 0.024% max sulfur, and 28 to 34% copper. As we noted in our first of this series, cobalt is considered part of the nickel requirement. Nickel and cobalt are typically found together in the ore that they are produced from. Separating the two to very high levels of purity increases the cost. Metallurgically very similar, we often see nickel plus cobalt considered as one element when it would not affect the performance of the alloy. This solid solution alloy is not hardenable by heat treatment. It can be strengthened by cold work. Depending on the specific composition of the material, it can either be magnetic or non-magnetic at near room temperatures of 70 to 120 degrees Fahrenheit. The temperature that this change in magnetic properties occurs is called the Curie temperature. Magnetic below the Curie temperature and non-magnetic above. If consistent magnetic response is an issue in an application, other alloys are likely better suited for use. Typical applications for this family of alloys are in marine environments and chemical and petrochemical processing equipment. Components of valves, fasteners, shafting, piping, and heat exchangers are common. Monel R-405 has the same basic chemistry as 400, but requires added sulfur to improve its machining characteristics. Sulfur range is 0.025 to 0.60 to 0.060%. 0.025 to 0.060%. Like 400, it is not hardenable by heat treatment. It is used mainly for screw machine stock applications. Other applications are not recommended. Monel K-500 is a higher strength alloy achieved by precipitation hardening heat treatment. Adding 2.3 to 3.5% aluminum and 0.35 to 0.85% titanium to the basic composition creates an alloy that can be heat treated to precipitate these elements and increase its strength. Solution annealing typically occurs at 18 to 1900 degrees Fahrenheit, followed by an aging at 1100 to 1125 degrees Fahrenheit for hot worked products. Cold work material achieves the highest strengths and is typically aged at 980 to 1000 degrees Fahrenheit. The chemistry of K500 also lowers the Curie temperature to well below 100 degrees Fahrenheit and is reliably non-magnetic at higher temperatures. This alloy is used where its higher strength or the magnetic properties are useful. Specifications for these alloys are in the B series of ASTM standards. SB for boiler and pressure vessel applications, AMS for aerospace, and NACE for petrochemical use. Specifications include the product form of bar, tube, plate, etc., along with the processing requirements for that application. So you know what I'm going to say. Check the spec. And when you've checked it once, check it twice. You can never be too careful. So thank you for tuning in to the second part of nickel alloys. And if you've made it this far, let's be honest, you like the material. Because anybody who made it this far wants to know about metal. So if you want to know about metal, click that little button and subscribe. You won't miss any of my future videos. If you have missed any of the previous videos, click here. Just check them out. Have a great day. This is Michael with Michelin Metals. I appreciate you tuning in. I'm out.